The coal, nuclear, and waste fuel cycle. Coal is cheap, abundant, and is a very versatile carbon feedstock for making both gas and liquid transportation fuels. But coal is more than that. It contains many elements useful in industry. Coal contains iron, aluminum, titanium, vanadium, zinc, magnesium, and other valuable elements. Coal also contains uranium and thorium, both which can be used as very valuable nuclear fuels. When coal is combusted, it releases a great amount of energy in the form of heat. With modern fired coal power plants, nearly all the coal ash is captured, and so all the valuable elements are captured as well. Currently, there are many uses for coal ash, but almost none of them separate out the valuable elements for sale because until now, this has been a very expensive process. The coal nuclear waste fuel cycle, we believe, will make it not only economically feasible to separate out these elements, but we believe it will be very profitable to do so. According to the International Atomic Energy Agency data, coal contains an average of about 2.08 parts per million of uranium and 4.58 parts per million of thorium. Although these concentrations are small, these components are significant when the vast quantity of coal mined and burned is considered. Analysis of U.S. coal samples show that many deposits contain far higher concentrations than the International Atomic Energy Agency's average values. For example, a 1979 U.S. Department of Energy report showed that some U.S. coal contained in excess of 103 parts per million of uranium. In 2012, the coal industry produced about 11,870 tons of uranium and 26,000 tons of thorium that could have produced $12.5 trillion in residential electricity at 8 cents per kilowatt hour. There were also 50 million tons of iron worth $40.8 billion. There were 152 million tons of aluminum worth $273.6 billion. There was also 19.5 million tons of magnesium worth $63.3 billion. And 7 million tons of titanium at a whopping $210 billion. And 260,000 tons of vanadium worth $8.84 billion, all put into ash piles that, if separated, the metals alone would be worth $561 billion. When energy and metals are considered, there are many more times the value than what the energy that was in the original coal itself when it was combusted to produce electricity. By far, the largest economic component is the amount of energy that is produced from thorium. That's $12.48 trillion. The economics of thorium are dependent upon the commercialization of LIFTR technology. LIFTR stands for Liquid Fluoride Thorium Reactor, which is a largely well-demonstrated and somewhat mature and proven technology. The coal, nuclear, and waste cycle works like this. Coal is burned in a clean, modern power plant that captures the ash and carbon dioxide. During the day, when energy demand is high, LIFTR produces electricity for the grid. During the night, when the demand is low, LIFTR processes coal ash and carbon dioxide. LIFTR uses the energy it produces to make supercritical carbon dioxide. Supercritical carbon dioxide can be used to extract and separate many of the valuable elements from the coal ash. This includes the thorium that powers the LIFTR. What is left of the coal ash still has organic material that has energy left in it, and other toxins like mercury and lead. Then the coal ash can be mixed with raw, untreated sewage and brown and dirty coal and municipal solid waste. This mixture is then again passed through the plasma gasifier, which produces a synthesis gas composed primarily of carbon monoxide and hydrogen, which can be converted into high valuable transportation fuels. The slag from the plasma gasifier can then be ground up and passed through the supercritical CO2 process again. This removes the remaining valuable byproducts and is then passed through the gasifier to produce a vitrified slag that cannot leach any of those toxins. This slag is usable as a lightweight but strong aggregate for concrete or blacktop. The steam can be condensed to provide purified drinking water free of toxins. Many of you will ask, why aren't we doing this now? Because up until this point, lifter has not been commercialized because there are very large and very expensive regulatory hurdles to overcome to commercialize lifter technology. It is quite possible all coal ash, brown coal, dirty coal, municipal waste, and raw sewage can be recycled into nuclear fuel, liquid transportation fuels, valuable metals, drinking water, and construction aggregate, which would eliminate piles of low-grade coal not suitable for burning, coal ash piles, landfills, and sewage treatment plants. The coal nuclear waste fuel cycle can make our skies and lakes bluer, our water cleaner, and our air better to breathe, all while minimizing carbon dioxide releases into the atmosphere. The coal nuclear waste fuel cycle is good for our future.